Let me record. And we said in a velocity time graph, the gradient gives the acceleration. So, එතකොට අපි gradient එකෙන් acceleration calculate කරා. And in addition to that, we also said whenever you have a graph, if you calculate the area under the graph, from that you get the displacement. This is what we did last week. So then we did some questions also. Like during the class, we did some examples. I asked you all to make some sketches, find acceleration, displacement, and all that. Then we did a different shape. Again, I asked you all to find acceleration. There you saw that it's a negative acceleration. So we got it as a deceleration. Then we found displacement. I told you different shapes of velocity time graphs that you could possibly get questions. Especially Lamai, for MCQs, they won't give you like big questions. You know, MCQs are supposed to be like short questions with like 4 answers. So you have to underline the correct answer, right? However, they may ask something like this, like local questions are but they might like kind of try to see if you understand the shapes of the graphs. So we talked about some commonly occurring shapes. Then we did a question. Which question is this, Lamai? Textbook. Okay, let me get the textbook real fast. You also open your textbook. You also open your textbook. I will also get my textbook real fast. This was question number, object starting from rest, 15, 6.
Miss, page 48. 42.
Page 42. Page 42.
Yeah.
Right. We were doing that example, no? We said we will do it on our own and then we will discuss. Right. Okay. Then, Lamai, I gave you all 2 homework, which is here. Miscellaneous exercise, question 3 and 4. Let's see miscellaneous exercise, question 3 and 4. All right. Let's quickly discuss the homework and then we'll come back to today's part, right? Today, we are going to finish this lesson and we are going to start lesson number 3. Okay, Lamai, I shared a new whiteboard. Those of you who cannot see the whiteboard, I will send the link in the main chat. In the main chat, there's the link. You can click on that link and weave the whiteboard. කාට පේන්නේ නැත්නම් ඒකෙන් click කරලා යන්න. Okay. Miscellaneous exercise question 3 and 4. Let's start by discussing question number 3. I will get the question to the whiteboard. Can all of you see this question? Yes, Shweta. Shweta, can you remind me at the towards the latter part එක class එක ඉවරෙද්ද වගේ මට පොඩි message එකක් දාන්න? Then I have to open that whiteboard and save it again. So, okay. This is a third question, miscellaneous exercise, to be specific on page 48. If the velocity of a body varied uniformly from 10 ms minus 1 to 25 ms minus 1 during a time interval of 5 seconds, what was the acceleration of the body? Now here, Lamai, they have not asked you to draw the velocity time graph in the Roman number 1, right? In Roman number 1, they have not asked you to draw the velocity time graph, but you have to find acceleration. What is the formula for finding acceleration, Lamai? What is the formula for finding
Final velocity.
Find the gradient
divided by time.
Yeah. So you can find acceleration by the gradient, but you need to have the graph. No? Here they have not asked you to draw the graph in step number 1, in Roman number 1. They have just given you some data and they are asking you to calculate acceleration.
Teacher, do we have to write the questions?
No, not at all. It's on the textbook, no? So just writing the answer is more than enough. And since we will be done with this lesson, I will send the worksheet probably tomorrow or day after tomorrow. එතකොට worksheet එකේ we have all the past paper questions relevant to this. Okay. So එතන worksheet එකේ ටිකක් discuss කරාම everything will be okay for us. Okay. Hari. Now we can't use gradient because this is not like a drawn graph, right? So we will use our equation. And what exactly is our equation? As you all said, acceleration equals final velocity minus initial velocity divided by time. Okay, now we will apply the values. From 10 ms minus 1 to 25 ms minus 1, what is the final velocity? What is the final velocity?
25 ms minus 1.
25 ms minus 1. So here for final velocity, I will put 25 ms minus 1. What is the initial velocity?
10 ms minus 1.
Yes, 10 ms minus 1. Divided by what is the time?
5 seconds.
5 seconds, good. So 25 minus 10 is 15. So 15 ms minus 1 divided by 5 seconds. And 15 divided by 5, we get 3. Now this is acceleration. Always remember, we have to write the correct unit. The moment you write the unit wrong, oglan kochchar mahansi wela answer ka work out kara, your answer, let's say the number is correct, but if your unit is not correct, that will be marked as a wrong answer. Okay. So it should be, since it's acceleration, it is ms minus 2. Did you all get this answer, Lamai?
Yes, miss.
Okay, others? Others? Okay. Hishma, are you a newcomer today?
Yes, teacher.
Okay. So I forgot to mention something. Hishma, Neja, and Shenali, since all three of you are newcomers, can you drop your WhatsApp number in the chat box so that it's easy for communication? Just drop your WhatsApp number in the chat box. I think some of y'all, your WhatsApp number might already be there, but just in case, drop it in the chat box. Huh? Okay, now we have to sketch the velocity time graph for the above motion and find the distance traveled during 5 seconds. Okay. Now we have to sketch the velocity time graph. Roman number 2. Now you know when you're sketching the velocity time graph, what should be in the y-axis? What should be in the y-axis?
Velocity.
Velocity. And I have told you already, when you are putting the quantity on the y or x-axis, within brackets, you also have to put the unit. Okay, that is very important. X-axis, okay, we have time, and within brackets, I put seconds. Now, time 0, අපි තියෙන data ටික විතරක් mark කරාම ඇති ළමයි. We don't have to put everything. 1, 2, 3, 4, 5 like that. We don't have to put everything. Just the data that is given, marking that is more than enough. So they say the initial velocity is 10, final velocity is 25, time is 5 seconds. So this is 0 second and this is the 5th second. ඕන මැද ටික අපිට fill කරන්න පුළුවන්. 1, 2, 3, 4. Okay. Starting, the initial velocity is 10. So when the motion is being started, it already has a velocity. Yagi velocity, starting velocity 10. Okay. And then a final velocity, that is 25. So, when this motion is starting, it already has a velocity of 10. And during the 5 seconds, it goes and gets a velocity of 25. This should be the velocity time graph that you should sketch. Did you all sketch it like this?
Yes, miss.
Okay. Others, give me a thumbs up if you all got the right answer and if you all understood. Okay. See, Balanapi, the very first time we did a velocity time graph, it was a bit difficult, no? But the more questions you do, the more familiar you get. Then after doing like a few questions, you will be okay. It won't be too difficult. Okay. You have to give some effort and practice and learn and focus and all that. After that, once you get the concept into your head, it's not very difficult. All right. So Roman number 3, I will do the answers here. The variation of the velocity of a certain object that traveled along a straight line is shown in the graph below. Find the acceleration of the object during the first 6 seconds. First 6 seconds කියන ළමයි මෙන්න මේ ටික. How do I find the acceleration from? Yes.
Miss, in the previous question, they are asking the distance too.
Sketch the velocity time graph for the above motion and find the distance. Okay, thank you for pointing that out. They are asking the distance also. How do you get the distance from this graph?
Area under the graph.
Yes, area under the graph. What is the distance you got here? Now, this is a graph. Sorry, 1 second. Now, this is the graph. No, area under the graph means the area that is below the graph. Did you all calculate what is the value you got for this area? Quickly tell. Just tell me whether it's right or wrong. Don't worry. What is it?
87.5.
87.5. Okay. What about others? What about others? No, what is the area here? Same thing. Okay, we'll see. Metana area kohaddi. Okay, let's write area under the graph. Because area under the graph is the distance or the displacement, right? There are 2 ways how you can get the area under this graph, right? If you look at the shape of the area under the graph, can you see that this looks like a trapezium? මෙහෙම parallel lens දෙකක් දෙපැත්තේ තියෙනවා, and then we have something like this. A quadrilateral with only 2 sides parallel, we call it a trapezium. So this has the shape of a trapezium. You already know how to find the area of a trapezium. From that, you can get it. So when you're getting the area of a trapezium, you take the 2 parallel lengths. Make a parallel length එකක්, මේ තව parallel length එකක්. So here, the distance, the length is 10, right? 10 plus here the length is 25. Divided by 2 multiplied by perpendicular height. Here the perpendicular height is this, which is 5. Okay, 5. So 25 plus 10 is 35. 35 divided by 2 multiplied by 5. 35 divided by 2 would be 17.5 multiplied by 5. Okay, we'll see. 17.5 multiplied by 5. 5 times 5, 25. 5 times 7, 35. Plus 2, 37. 5 times 1, 5. Plus 3, 8. With decimal point, you get 87.5. Since area under the graph is 87.5, we know area under the graph of a velocity time graph is always the displacement, or sometimes we just call it distance. Therefore, displacement would be happy haritam unit එක දාන්න ඕනේ නැත්තම් wrong. It's 87.5 meters. Or you can do it like this. If finding the area for trapezium a bit too confusing for you, what you can do here is that බලන්න මෙන්න මේකනේ අපි දැන් මේ හොයන්න ඕනේ මේ shape එකනේ. මෙයාව මෙතනින් අපි බෙදුවොත් if I divide here this is a rectangle and this is a triangle. What ඕනනම් එහෙම දෙක වෙන වෙනම හොයන්නත් පුළුවන්. මම ඒකත් පෙන්නන්නම්. But like it's easier to find the area of the trapezium straight away. But it's totally up to you. Whatever the way you do, as long as the final answer is correct, you will get marks. මම අනිත් විදිහත් කියන්නම්. Now this is a rectangle, no? How do you find the area of a rectangle? Length into breadth. Here seems like this is the length, no? මෙතන 10, මෙතන 5, right? So 10 multiplied by 5. 10 multiplied by 5. That is the area of the rectangle. Plus, there's a triangle at the top. How do you find the area of a triangle? Half into base into perpendicular height. Okay. So, half into base is this, which is 5. Perpendicular height is this. මෙන්න මේ gap එක කියන්නේ 25 minus 10. So, මෙතන gap එක is 15, no? That is the same thing here, no? So, that is 15. So, perpendicular height is 15. So, this is the area of the rectangle. This is the area of the triangle. Then 10 times 5 is 50 plus 5 times 15 is 75. 75 divided by 2. 50 plus 75 divided by 2 is 2 times 3 is 6. 2 times 3 is 6. 1 remaining. 15 means 2 times 7, 14. Then මේ දෙනවා වැඩි කරාම you get 87.5. Therefore, distance is equal to 87.5 meters. Same thing both ways. Either you can get the area of the entire trapezium or you can divide into the rectangle and the triangle and you can find the area separately and add. Is that clear? Is this step clear? Did you all get the answers here? All right. I'm sorry I missed that. So let's move on to Roman number 3. So they're asking here, this is a velocity time graph, no? They're asking the acceleration of the object during the first 6 seconds. First 6 seconds කියන්නේ මෙන්න මේ set එක. I mean, that's the first part of it. But the first part එකේ the graph takes a shape like this. And මෙන්න මේකේ තමයි they're asking the acceleration. When you have a velocity time graph, how do you find the acceleration? When you have a velocity time graph, how do you find the acceleration? Yes? When you have a velocity time graph, how do you find the acceleration?
We find the gradient.
We find the gradient, right? So, Mithana, they're asking during the first 6 seconds. That means the part that I highlighted in red. So, api ekhe gradient එක හොයන්න ඕනේ. We know to find gradient, we need at least 2 points. Then මේ මැද තියෙන points මම දන්නේ නැහැ, but I know the beginning point. Here the x value is 0, y value is also 0. I also know that the points mama done but I also know the ending point. Here the x value is 6, y value is also 6. So this is the x value of the first point, so I put x1. This is the y value of the first point, so I put y1. This is the x value of the second point, so I put x2. This is the y value of the second point, so I put y2. Now we will calculate gradient. Gradient equals Now we have done this multiple times already. y2 minus y1 divided by x2 minus x1. And what is y2 here? 6. What is y1? 0. So 6 minus 0. What is x2 here? 6. What is x1 here? 0. Again, we have 6 minus 0. In the numerator, 6 minus 0 is 6. Denominator also 6 minus 0 is the same as 6. So 6 divided by 6 means 1. And we know from the gradient we get the acceleration. So we write acceleration equals, gradient is equal to acceleration. So that is also 1. But you have to put the unit, ms minus 2. Is that part clear to all of you? Others? Okay. Find the mid traversed කියලා කියන්නේ ළමයි traveled කියන එකම තමයි. Traversed is the same as traveled, right? Just another term. Find the distance traversed by the object during the first 6 seconds. First 6 seconds means now they're asking the distance, which in other terms is displacement, right? So in a velocity time graph, we already talked about it. How do you get the displacement area under the graph? Okay. So this is the first 6 seconds can make it. So area under the graph is this triangle. Okay, that's easy, no? So we just have to find the area. Ma metana karana B එක තියෙන distance ne. So let's do this. I have to find the area under the graph. I will just write area. Now this is a triangle. So how do you find the area of a triangle? Half into base. Base is this. Metana කොච්චරක් තියනද 6. Into perpendicular height. Perpendicular height is here. How much is there? That is also 6. So 6. Now 6 times 6 is 36. 36 for 2 can divide කරාම we get 18. එහෙනම් area එක 18. And we know area gives the displacement. Therefore, displacement or distance doesn't really matter. Displacement equals, අපි හරියට unit එක දාන්න ඕනේ. We have to write 18. Unit is meters. So it's 18 meters. Is that clear? Give me a thumbs up fast. If any of you have any questions, ask lamai, because better to clear any doubts before we move on. Okay, after the class, I will just go through and I will understand. Even if I don't understand now, if I go through it later, I will understand. Sometimes when you get questions, you think that might be a stupid question, and you might even feel a bit shy to ask during the class. But sometimes, the questions that you think are stupid, others also might have the same question. Explain clear. There are no questions as stupid questions. Okay? Whatever the question you get, it's fair. I mean, that's because you didn't understand. So we can discuss it during the class and we can clear it off. Okay? Okay. So let's move on to C. C, what is the distance traversed at uniform velocity? Uniform velocity means that the velocity is not changing. Velocity is not changing. Now they are asking the distance now. Distance means displacement. Displacement, how do you get area under the graph? The metana area right? Looks like a square or rectangle, we will see. So I have to find this area. If I find this area, I can say that it is equal to displacement, no? Okay, let's do that. Uniform velocity area. Area. Then area under the graph just area. So length into breadth, right? So length is 6 to 12. Metana gap 6, right? Then breadth, this. Methana 0 in our 6 වෙනකන්නේ. So that is 6. This gap is 6. So 6 times 6 is 36. I'm sorry. 6 times 6 is 36. If the area is 36, we can say displacement is 36 meters. That is the displacement of this middle section where the object is moving in uniform velocity. Is that clear, Lamai? Before we move on to the last part, is that clear? Others, give me a thumbs up if you understood, if you got the answer. In the acceleration part, which is 3 Roman number part A, okay? I found the acceleration using the other equation, which is final velocity minus initial velocity divided by time. And I got the same answer. Is that correct, or do I have to go with the gradient? Generally, if you take O-level questions or certain term test questions, then graph එකක් දීලා නැත්තම් graph එකක් දුන්න නැත්තම් අපි acceleration හොයන්නේ මේ විදිහටනේ. We find acceleration as acceleration equals final velocity minus initial velocity divided by time. So, with the graph, we said we will use gradient. With the graph also, you can use this thing. So, that is a good question. The thing with most marking schemes is that if they give you the graph, or if there is a graph, they would prefer you to use the gradient method rather than the formula. Okay? For some marking schemes, formula එක ලියලා තිබ්බට ලකුණු දුන්නා ප්‍රශ්නයක් නැහැ. But if there is a graph, better to always go with the gradient just to be safe. Because we don't know, sometimes the marking scheme can be very flexible. Sometimes the marking scheme can be quite strict. But if you play it safe, however the way marking scheme is, you will get the marks. If so, if there is no graph involved, use this equation. Acceleration equals final velocity minus initial velocity divided by time. If there is a graph involved, find acceleration using the gradient method. For now, it's okay, but next time, do it like that. Is it clear, Jituli?
Yes, miss.
Okay. D. They are asking, find the deceleration during the last 3 seconds. Last 3 seconds, we know deceleration is the same as acceleration, no? The only difference is that deceleration is negative acceleration. Acceleration wala negative sign ekak tiyena, that is deceleration. Okay? So, මෙන්න මේ part එක ගැන තමයි දැන් කතා කරන්නේ. We have to find deceleration. Deceleration is the same as acceleration, just the negative. So how do you find acceleration from the graph? You use the gradient. Let's just use the gradient, right? Then we know to find the gradient, we need 2 points. Then my graph එකේ මැද points මොනවාද මම දන්නේ නැහැ, but I know the beginning point. In the beginning point, x value is 12. Y value is 6. I don't know any the middle points, I don't know. But this is the last point. The x value is 15. The y value is, the y value is 0. The y value is 0. When the graph is now graphic, then make an mulimati point. So x value of the first point, so x1. Y value of the first point, so y1. X value of the second point, so x2. Y value of the second point, so y2. Now let's find gradient. Gradient, I'm using different colors, so it will be easier for you to like later check, right? Colors use This is just for you to understand it better. Okay, let's see. Y2 is 0, Y1 is 6. So 0 minus 6. X2 is 15, X1 is 12. X2 is 15, X1 is 12. 0 minus 6 is minus 6. 15 minus 12 is 3. And minus 6 divided by 3 is minus 2. What is the acceleration here? Acceleration is minus 2 ms minus 2. However, they are not asking acceleration, they are asking deceleration. And what is the deceleration here, Lamai? What is the deceleration here? Yes.
Plus 2.
Plus 2, yes. Acceleration came a negative or a deceleration. Here the negative sign I remove, then I get deceleration. If acceleration is minus 2 ms minus 2, deceleration would be 2 ms minus 2. Like that. All clear? Thumbs up? All right. For any corrections, here. This is Roman number 1. This is Roman number 2. Roman number 3. Yeah? For corrections, I will give you a few minutes because in the last classes also, I didn't give you time to do the recorrections. No? But I'm going to recorrections at a time then. Okay. I will give you a few minutes to do the recorrections. Also, I have a little news for you. On March 2nd, which is in another 2 weeks, we are going to have a free seminar for grade 10. Right? Grade 10 grade there's going to be a free seminar. In the science seminar, I will let you know which subjects I will be doing. But Ogolanda compulsory you are coming to the class, no? But that is just for everybody. It's like a free seminar. It's open for public. Any student can join and learn. So you don't really have the need to join because you're anyways in the class. So whatever the lessons we do it that way. Seminar but like just for everybody, just all students can join. So if you have any friends who might be interested, I will share the details so you can share it to them. On March 2nd in the morning, we will be having a science free seminar. And during the noon time, we will be having a maths free seminar. Dekhe mapi karapu karana lessons walima tamai karanne. So class in a katida don't worry, but if you have anybody who is interested in joining, they can join. I will share the details in the group. Quickly copy down. I will set a timer. I will give you 3 minutes to do corrections. Quickly. Yes, of course. You also can join the seminar. It's free for everyone. You can join. You can bring your friends if there's anybody who's interested. Most probably, we might be doing either the second lesson or the third lesson. Academy second lesson is the lesson that we're doing just now. Or the third lesson. I will decide it for sure and let you all know. Maths ke, most probably we will be doing binomial expressions or fractions. Again, we have not decided yet. But you can, of course, join. Have a class. But if you want to listen to it for another time, you can join. For the newcomers, I will send a Google form in the chat box, and I will also send it in the group that you guys are in. So if you're interested in confirming, you can confirm through that link. Okay, Lama, your time is up. We have the fourth question also. Let's quickly discuss that. Fourth homework. Yeah, no? Okay. Let me get the fourth question to the textbook. Sorry, to the whiteboard. Now, in the fourth question, you have to draw the velocity time graph on your own. They have not given you. You have to draw it. Okay, give me a second. An object starting from rest and moving on a straight. Starting from rest. If this is starting from rest, what is the initial velocity?
0.
0. Moving on a straight line at a constant acceleration and acquires a velocity of 12 ms minus 1 in 8 seconds. Thereafter, it moves for another 4 seconds at a uniform velocity 12 ms minus 1. Ultimately, it decelerates for 4 seconds and comes to rest. And I antimata 0 වෙනවා. Please give me a second, Lamai. My laptop is about to die. Sorry. Okay. So, okay. Now we will draw the velocity time graph. බලමු step by step කොහොමද අඳින්නේ කියලා. See if you also drew in the same way. Shall we draw it on the method? So this is the y-axis and this is the x-axis. I drew it a little longer. So y-axis we have velocity. I told you you have to put the unit within brackets, right? ms minus 1. In the x-axis we have time. Within brackets you have to put the unit seconds. Let's go back to the question. Starting from rest. Starting from rest means it's starting from 0, right? Initial velocity is 0 here. Moving on a straight line at a constant acceleration acquires a velocity of 12 ms minus 1 in 8 seconds. Within 8 seconds, it acquires a velocity of 12 ms minus 1. That means the graph should be like this. Like this. Okay. Then let's see. Thereafter, it moves for another 4 seconds at a uniform velocity of 12. May 12 ki a uniform velocity, it moves for another 4 seconds. Another 4 seconds. After another 4 seconds, what would be the time here? 12, right? So you can't put 4 here. After another 4 seconds means from 8, you have to count 4 seconds. That would be 12 here. And a uniform velocity of 12. May 12 ki uniform velocity like this. Okay. Ultimately, it decelerates for 4 seconds and comes to rest. Decelerate and then speed velocity and it comes to rest within 4 seconds. So you have to count another 4 seconds from 12. 13, 14, 15, 16. So during these 4 seconds, this decelerates and comes to rest. Decelerate velocity it becomes 0 like this. Did you all draw the velocity time graph like this? You don't have to measure and do all that. Just writing the values is more than enough. I hope it's clear. So Roman number 1, sketch the velocity time graph for the above motion, which we just did. Roman number 2. What is the acceleration of the object during the first 8 seconds? First 8 seconds means we are talking about this section. I told you when you have the velocity time graph, better to use the gradient method. For gradient, you need 2 points. So I have the first point, which is 0, 0. Then mother points monad mama danna. Then here, I know the ending point. There the x value is 8 and the y value is 12. This is the x and y values of the first point. So I put x1, y1. These are x and y values of the second point. So I put x2, y2. Okay. Let's calculate the gradient. At the gradient again, we get the acceleration. Gradient equals final y2 minus y1 divided by x2 minus x1. y2 is 12, y1 is 0. x2 here is 8, x1 is 0, right? x2 is 8, x1 is 0. So 12 minus 0 is 12, 8 minus 0 is 8. So you just have to divide this. 4 times 2 is 8, 4 times 3 is 12. 3 divided by 2, you get 1.5. If the gradient is 1.5, acceleration would be 1.5 ms minus 2. Is this clear to all of you, Lamai? Give me a thumbs up if it's clear and if you all got the answer. Others? Thumbs up then. I'm asking all of you, right? There are 18 of you and all of you need to understand this. Newcomers can be excused because they were not there for the previous lessons. But even if you if there are any doubts, you can ask too. Okay, for everybody. So I'm asking whether you understood for everybody. Like putting a thumbs up is not a big deal, right? I'm not asking you to unmute yourself. You can just put a thumbs up just so I know you understood. All right, let's move on to Roman number 3. What is the distance traversed by the object during the first 8 seconds? First 8 seconds wala distance එක කියලා කියන්නේ that is the same as displacement. And how do you get the displacement of a velocity time graph? You get the area under the graph. Now here, this is the graph. So area under the graph means we have to get the area of this triangle. Okay, that's not very difficult. We can do it easily. I will do the Roman number 3 here, Lamai. Okay, area. It is a triangle, so we know how to find the area of a triangle. Half into base. Here the base is 8. Into perpendicular height. Perpendicular height is 12, so perpendicular height is 12. Okay, let me close this. So 2 times 1 is 2, 2 times 4 is 8. Then 4 times 12 is 48. If area is 48, we know distance or displacement is 48 meters. Is that clear to all of you? Did you all get this answer? Give me a thumbs up. I hope everybody did the homework. Okay. I hope everybody did the homework. If you don't do the homework, I would say don't come to the class. Okay? Because we take homework very seriously. Can you see the time now? We have been discussing homework for about 1 hour. I mean, I did start the class a bit late, but almost 1 hour we have been discussing homework. Mokada class එකේ කරන ටික ළමයි anyways we are discussing. I'm teaching, you're learning. But homework is where we do a discussion. Homework is the part that you do alone. And then we discuss it. So that's very important. Okay. So I give a lot of priority to homework. And therefore, you must do the homework. If you didn't do, I mean, unless you have a very good reason. If you have a very good reason, it's okay. You can be excused. But if not, you should have the discipline to do the homework before the class. Okay. Appi ara online setting එකේ ඉන්න හින්දා I don't have a way to check if you did the homework, but don't take advantage of that. Okay. All right. Roman number 4. What is the distance traversed at uniform velocity? Uniform velocity means this part. They're asking the distance traversed. Distance is the same as displacement. You get the area under the graph. That means we have to calculate this area. Again, not very difficult, no, because this is a rectangle. Rectangle එක area එක වෙනක අපිට ගොඩක් අමාරු නෑ නේ. Okay, let's find the area. Area. Length into breadth. So this is the length. Length is 12. Here breadth 18 and 12 when I count the gap is 4. So the breadth is 4. Length is 12, breadth is 4. 12 times 4. 12 times 4 is 48. Therefore, we can say displacement is 48 meters. Is that clear to all of you? Did you all get this answer? Okay, others? Okay. Fifth Roman number. Last part, then we'll move on to the lesson. What is the deceleration of the object during the time interval 12 seconds to 16 seconds? 12 to 16 means they're talking about this part of the graph. They're asking the deceleration. And we know deceleration, we have to find acceleration, right? And how do we find acceleration? From the gradient. And to find the gradient, we need 2 points. So this is the graphic. This is the first point. X value is 12. Y value is also 12. So X value is 12. Y value is 12. The may part, okay, this is the first point. So I put X1 and Y1. Then Madeva points up at so then I have this point. May point okay, X value is 16. Y value is 0. This is the second point. So this is X2 and Y2. So let's calculate the gradient.
Excuse me, miss.
Yes, Asheli.
Can you give us time to do a recreation, please? Recorrection, please.
Yes, of course. In this, I will give you time.
Okay,
The
thank you.
previous one, you did the recorrection, no?
Yes, please.
Okay, all right. I'll give time. Then we'll calculate gradient. Gradient equals y2 minus y1 divided by x2 minus x1. Now we are spending so much time to learn this, no? You have to revise, right? Ogalang, other make again, if you close that chapter and you don't go through this lesson for, let's say, a month, you will have forgotten most of it. And then you will have to spend more time to study all of that all over again. And there might be even parts that you don't understand. That is how human memory is, Lamai. Amataka venawa kiyanek is not something abnormal. And if you forget, that doesn't mean that there's a problem with you. That's how it is. Let's say I stop teaching this O-level syllabus for, let's say, 1 or 2 years. There could be parts in the syllabus that I might have forgotten. Because we are all human beings. Forgetting is very normal. But since you know you're forgetting, what you need to do is constantly revise. And I don't mean that you have to revise this every single day, but at least make it an so maybe revise. So next week, allocate a time slot and you revise it next week also. I mean, for science, we have only done 2 lessons so far. So revising should not take too much time. At least revise it will stay fresh in your memory. Otherwise, you definitely are going to forget things here and there. Okay? I'm telling you this because now there's a batch who went, whose O-levels just started today. So, they have forgotten most of this because this is grade 10 second lesson now. So, when we were doing the past paper revision, they have forgotten some of this. Right? I have to tell you, every week when you are coming to the class, make sure you revise what we have done previously. So, mama other uganta Q&A next week okay, because randomly I do like question sessions. I do question and answer sessions, and then I call your names and I ask questions. I would randomly do that. Okay, so make sure you go through everything before you come to the class. Okay, so here y2 is 0, y1 is 12. x2 is 16, x1 is 12. So y2 is 0, y1 is 12, x2 is 16, x1 is 12. 0 minus 12 is minus 12, 16 minus 12 is 4. And minus 12 divided by 4 means minus 3. If gradient is minus 3, what is the deceleration. What is the deceleration? Alamai? So if the gradient is -3, acceleration is -3 ms -2. So what about the deceleration?
3 ms minus 2.
3 ms minus. Deceleration? Yeah, they're asking us deceleration. So deceleration is minus එක හැලුවා, we just write 3 ms minus 2. That is how you get the deceleration. Let's quickly go to the last part as well. Find the displacement of the object after 16 seconds. It can be 16 seconds ගියාට පස්සේ. What is the displacement of the object? You can just look at this and tell. ඒගොල්ලෝ අපේ අහන්නේ මේක නෙවෙයි. They are not asking us this displacement. They are asking us the displacement after 16 seconds. What do you think? What do you think? I have a question. Explain how to get y2 in the fifth question. Fifth question can make and y2 is this. Here, whenever you get the x and y values of a certain point, or a point එක දිහා බලාගෙන ඒකත් එක්කම x axis එකේ තියෙන value එක ගන්නවා, ඒකත් එක්කම y axis එකේ තියෙන value එක ගන්නවා. Now we are talking about this point, no? මේ point එක ගත්තොත් මේකත් එක්කම, then this is the x axis. X axis එකේ තියෙන්නේ 16, so that is the x value. ඒකත් එක්කම y axis එකේ මොකද්ද තියෙන value එක? Is it y1, y2, y3, y4, y10, y11, or is it just y0? මේ y axis එක පටන් ගන්න තැනම නේද එතන y value එක. Then that should be y equals 0 නේද? If you look at this point, the y value corresponding to that is this here. That is exactly where the y-axis starts. So the y value there should be 0. Is it clear? Okay. If it's not clear, let me know. I will explain again. I hope everybody else also understood that. ඒක ගොඩක් වෙලාවට උගන්න වර්ධින point එකක්. Good that you asked. Then බලන්න ළමයි, displacement of this part කියලා කිව්වොත් we can just get the area of this part and be done with it. But they're asking us the displacement after 16 seconds. If they're asking you the displacement after 16 seconds, they are talking about this entire displacement. මේ මුළු motion එකම ගිහිල්ලානේ after 16 seconds, this entire motion has taken place. And they are asking us the displacement of this entire motion. එතකොට, now this green color area, I have found the displacement. Red color one also I have found the displacement. I will find the displacement of this part also, and then I can later add all the three. Okay. So this is also a triangle. A කොටස displacement එක නෙවෙයි ළමයි අහන්නේ. What is the displacement after 6? I'm sorry. What is the displacement after 16 seconds? So that means they're asking us the total displacement. So let's calculate the area. Half into base. Base is here, the gap is 4, no? So base is 4. Perpendicular height. So here the perpendicular height is 12. Okay, so here 2 times 1 is 2, 2 times 2 is 4. And 2 times 12 is 24. The area is 24. Therefore, in that part, the displacement we can say 24 meters. They are asking us the displacement after 16 seconds. So that means they are asking us the total, total displacement. total displacement, now you have to add all the three displacements. In the green color area, the displacement we got as 48 meters. In the red color area, again, we got the displacement as 48 meters. In the purple area, we got the displacement as 24 meters. So, 48 plus 48 is 96. 96 plus 24. 6 plus 4 is 10. 9, 10, 11, 12. 120 meters. We just add all the three. Is this clear to you, Lamai? Everybody? All right. I will give you 5 minutes for recorrections. 4 to 5, yeah. I'll set the time of 5 minutes. Once this is done, we will do the last part of the second lesson. Okay, quickly do the recorrections. While you do the recorrections, give me 2-3 minutes, Samai. I will be back. But while I come, quickly finish all the recorrections. Have you all finished, Lamai? Give me a thumbs up if you have finished doing the recorrections.
Excuse me, miss.
Yes.
When you put acceleration, you put -3 ms -2. And when you put deceleration, you put 3 ms -2, right?
Yeah.
So every time you put -2, like if it's acceleration, it doesn't change to when it comes to deceleration, it doesn't change to 3m s2, right? Because it's the value, I think.
No, yes, only the minus of the value only is we remove it. The unit is the same because acceleration, deceleration is the same thing. The only difference is that acceleration can velocity value deceleration means velocity advenaka. But the unit doesn't change, only the
Okay.
minus of the value changes.
Okay, miss.
Okay. Okay. Put the topic gravitational acceleration. This is the last part. Yes, Stephanie. Quickly write. Gravitational acceleration. I will slowly move on, no? So you are probably at the last part, no? Okay. Then gravitational acceleration means something like this. Now, when you're just standing or when you're just like you're listening to the class while sitting on a chair or something, do you think there's a force acting on you? Is somebody pulling you when you're just standing or sitting or whatever? Even when you're just like
the topic again.
Gravitational acceleration. Let me put the topic. Gravitational acceleration. So when you are just standing or sitting or whatever, do you think is somebody pulling you? What is pulling you? Yes. Earth is pulling you with gravity, right? When Earth is pulling you with gravity, Lamai, you might not believe this, but even when you are not moving, there's always an acceleration from you. Again, accelerate. So now when I'm on like an upper floor, right? So why am I not falling down? Because there's a concrete floor beneath me. Let's say there's like a hole or something. Mame hole එක ළඟට ගිහිල්ලා එතනින් අඩිය තිබ්බොත් I'll fall down. So even when you're just walking on the ground, walking anywhere or standing anywhere, the only reason why you're not going down is because there's the floor or there's the ground. Ground එක තිබුණ නැත්නම් you will go down. For an example, something like this. Now let's say there's a child. So then මෙයා මෙහෙම ඇවිදගෙන ඉස්සරහට යනවා. Now here the child is not like going through the ground. Ground එක උඩ ප්‍රශ්නයක් නැතුව ඉන්නවා. But here there's like a massive pit. එයා මෙන්න මෙතනට අඩිය තිබ්බොත් මොකද වෙන්නේ? This child will fall because of gravity. So this child is accelerating downwards. We call that gravitational acceleration. එයා මෙතනදී accelerate උනේ නැත්තේ මොකද මේ පල්ලෙහා ground එක තියෙන හින්දානේ. පල්ලෙහා there's a ground. Right? The ground or the earth. But දැන් මෙතන ලොකු පිට එකක් නේ. එතකොට මොකද වෙන්නේ? මෙයා මෙතන අඩිය තියපු ගමන් this child will be accelerated down like that. So all of us have an acceleration downwards towards the gravity. The only reason why we are not accelerating is because there's the earth or the ground beneath us. ඒකින්ද එතනින් අපි accelerate වෙන්නේ නැහැ. නැත්නම් අපි හැමෝටම acceleration එකක් තියෙනවා. So now this part, if you listen to this very carefully, you will understand everything very well. But එක වෙලාවකවත් එක තප්පරයකවත් don't let your attention divert. Okay. So this is what I'm going to do. I'm going to my balcony and I'm going to drop an object. මේ තියෙන මගේ object එක. I go to the balcony and I just drop it. I don't like throw it. I just drop it. What do you think is the initial velocity of this object? මම එහෙම drop කරන්නේ නැහැ. මම නිකම් එහෙම අතාරිනවා. Sorry. I don't throw it. I just drop it. I just lose my grip on it. What do you think is the initial velocity?
Zero.
Initial velocity is 0. If I threw it down, there could have been some velocity. But mama nikam mehema atarina vitarai. So initial velocity is 0. Now, Lamai, this is what happens. Now this object is moving down. No, this object is moving down. Down kila penna, I will draw an arrow downwards. So sorry, what is this? So now, this object is slowly going down like this. Now 1 second has passed. 1 second has passed. During this 1 second, the object now has a velocity of 9.8 ms minus 1. Now, at the very beginning, the initial velocity was 0, no? But within 1 second, it got a velocity of 9.8 ms minus 1. Okay. And it keeps falling down like this. Another second passes. Miss slow motion, huh? We're just like slowly talking about it. Another 1 second passes.
Teacher, can you explain again, please?
Yes. Now here the initial, now I just drop it. So the initial velocity is 0. So now it's falling down. While it is falling down, after 1 second, if you are able to get the velocity, it would have 9.8 ms minus 1 velocity. Ekane within 1 second, velocity ka වැඩි වෙලා. Now the velocity is 9.8 ms minus 1. Is that clear, Sasheli?
No.
Okay, so like this. Do you understand? Now when I drop it, the initial velocity is 0. Is that clear?
Yes.
Okay. Now, dama drop kara, dama mukut karana, it's just falling. When it is falling after 1 second, now the velocity has increased. So when it is falling, the velocity is gradually increasing. Within the first second, the velocity has increased to 9.8 ms minus 1. Ekane dama enne speed එක වැඩි වෙනවා. හරියට නිකන් when you're in a vehicle, if the driver steps on the accelerator, the speed of the velocity will gradually increase, right? ඒ වගේ මේ object එකේ දෙන්නේ velocity එක වැඩි වෙනවා. Initially the velocity was 0. Within 1 second, now the object has a velocity of 9.8 ms minus 1. Is that clear?
Yes.
Okay. Now ඊළඟට තව second එකකින් ඔය velocity එක බලනවා. Now it has a velocity of 19.6 ms minus 1. Yeah, it automatically increases. වා මුකුත් කරන්නේ නැහැ. මේ ඔක්කොම කරන්නේ gravity වලින්. ඒ gravity pull කරනවානේ. ඒකට accelerate වෙලා පල්ලෙහාට යනවා. When you drop objects, objects love to fall down. Why? Because gravity is there. Gravity is always pulling the objects. That is why n velocity එක වැඩි වෙනවා. Now the velocity is 19.6 ms minus 1. Now මේ බැටරෙකුට another 1 second passes. Another 1 second passes. Now the velocity is 29.4 ms minus 1. See, it's gradually increasing. Okay? And මෙන්න මෙතනදී තමයි යා මෙහෙම ground එකට වැටෙන්නේ. So here it stops. So you drop it. Initially the velocity is 0. So it is falling down. Within 1 second, the velocity has now increased to 9.8. Again, it's falling down. Within another second, now the velocity is 19.6. And another 1 second passes, and now the velocity is 29.4 ms minus 1. So gradually the velocity has increased. That means it is an acceleration. Okay, so balanna then මෙතන 0 ඉඳන් 9.8 වෙනකන් velocity එක වැඩි වෙලා by 9.8 ms minus 1. From 9.8 to 19.6, කොච්චර වැඩි වෙලාද velocity? What is the difference? How much has the velocity increased? How much has the velocity increased? Check the difference between these two. You can subtract 9.8 from 19.6.
Another 9.8.
Another 9.8. Very good. So here, this has again increased by another 9.8. What about from 19.6 to 29.4? How much has the velocity increased? The difference. Subtract and tell me the difference.
Another 9.8.
Another 9.8. Every second, the velocity has increased by 9.8. May motion ekata, can you calculate the acceleration alone? May mukut liyanne pa. I will separately give a note. Just somewhere on like a rough work paper. Now you have the initial velocity 0. You have the final velocity 29.4. You know the time 1, 2, 3. So it's 3 seconds, right? So can you calculate the acceleration for this motion? You know acceleration equals final velocity minus initial velocity divided by time. Calculate it quickly. Quickly calculate and let me know.
9.8.
Okay, Chituli says 9.8. Others also calculate and let me know. Quickly. Others, quickly.
9.8.
9.8. Okay, we'll see. Acceleration. I'm just writing it roughly. Acceleration equals final velocity minus initial velocity divided by time. This is our formula, right? If you take this entire motion, final velocity is 29.4 ms minus 1. Minus initial velocity in our motion is 0. Divided by time is 1, 2, 3, so it's 3 seconds. So 29.4 you have to divide by 3. 3 times 9 is 27, 2 remaining, 2.4. That is 3 times 8. So you get 9.8 ms minus 2. That is correct. Lamai, this 9.2 ms minus 2, we call it gravitational acceleration. That means this is a constant value. Earth එකේ සාමාන්‍යයෙන් gravitational acceleration කියන එක constant value එකක්, that is 9.8 ms minus 2. That is the gravitational acceleration. That means when you drop an object, every second the velocity is increasing by 9.8. Every second the velocity is increasing by 9.8. Therefore, gravitational acceleration is 9.8 ms minus 2. Up to that point, is it clear? Give me a thumbs up, everybody. Others? Kwanit kattiya. Did everybody understand? Okay. Now there's this is the correct value. 9.8 is the correct value of gravitational acceleration, but there's a little problem. Why? 9.8 has a decimal value, decimal number එකක් නේ. ඒතකොට calculations කරද්දී හරියම අමාරුයි. It's a bit of a struggle. Right? Decimal values අහම calculations වලදී පොඩ්ඩක් අමාරුයිනේ. ඒක හින්දා, yes, I will explain it again. So here, did you sorry. Did you understand this diagram, Chalukya? Like initial velocity 0, හැම second එකේම 9.8 වැඩි වෙනවා. So 0 ඉඳන් first second එකේ 9.8 වැඩි වුණා. So the velocity is 9.8 ms minus 1. Then in the next second, another 9.8 increase. Now the velocity is 19.6 ms minus 1. In the next second, another 9.8 increase. Now the velocity is 29.4 ms minus 1. එතකොට අපි acceleration කියන්නේ, now we know acceleration equals, මම කටුවට ලියන්නේ roughly, final velocity minus initial velocity divided by time. Is this formula clear to you, Charukya? Okay. If you take this motion, can you see the final velocity is 29.4 ms minus 1? That is the ending velocity. So final velocity is 29.4 ms minus 1. Initial velocity is 0. 0 නං යාව දාන්න ඕනේ නැහනේ. Time, totally look at the time here, 1 second, 1 second, 1 second, altogether 3 seconds. So the time is 3 seconds. So we divide 29.4 by 3. 3 times 9 is 27, 2 remaining, may 4 gannawa 24. I put the decimal here. 3 times 8 is 24. So acceleration is 9.8 ms minus 2. Is that clear, Chalukya?
Yes, teacher.
Okay. That is how we got this 9.8. This is a universal number because we say in Earth, when you consider Earth, gravitational acceleration is 9.8. But I told you there's a bit of a problem. No, why? Because there's a decimal number. Ekinda lamai api, in your syllabus, we round it off. 9.8 කෙනෙක් අපි round off කරලා අපි gravitational acceleration ඉගෙන ගන්නේ 10 කියලා. 10 ms minus 2. So that means every second the velocity is increasing by 10. Give me a second. Sorry, okay. So that means, Lamai, gravitational acceleration 10 ms minus 2 means, now this is a real thing. 9.8 is a real thing. Why we don't use it? Because it might complicate our calculations. Since now we are using 10, that means every second the velocity is increasing by 10. After 1 second, now the velocity is 10 ms minus 1. Another second goes, now the velocity increases by another 10, so now it's 20. After another second, velocity increases by another 10, now it's 30. This is what we are going to learn. So every second, velocity is increasing by 10. So our make it on acceleration calculate kalabana, you will get 10 ms minus 2. So this is what we are learning. Is this clear to all of you, Lamai? Give me a thumbs up if it's clear. Others? Now, we are coming to a very important part. Tam mukut liyan pa, don't write anything, don't copy down anything because I will give you plenty of time. Just listen to this. This is important. This is a bit difficult. That's why. I'm going to ask you a question like this. What is the height from which the object was dropped? Mangahanawa, what is the height from which the object was dropped? Eken apen ahanne menna me height එක. මෙතන ඉඳන් මෙතනට object එක drop කරපු height එක මොකක්ද කියලා මම අහනවා. How do you calculate this height? When I ask you height, how do you calculate this height? Any ideas? බලන්න ළමයි, in a horizontal motion, දැන් බලන්න අපි මේ කතා කරපු ඔක්කොම බලන්න examples වල අපි කතා කරේ objects starting from rest, moves like this, moves like that. So they're all horizontal. මේ පැත්තට තියෙනවා. ඒතර ඒවැ displacement කියලා කියන්නේ, now here the motion is from top to bottom or bottom to top. It's vertical. So horizontal motion එකක displacement කියන එකම නේද vertical එකේ height කියලා කියන්නේ. Height means displacement, right? Did you all understand that? Because height means the distance, no? Distance from which it was dropped. So height means displacement. Is that clear to you? So if I'm asking you the height, what you have to find is displacement. Okay? Because here height means the distance that the object was dropped from. That means in a velocity time situation, we call it displacement. ඔගලන්ට graph එකක් දීලා නැහැනේ මෙතන. graph එකක් තිබ්බා නම් how do you find displacement? From area under the graph. But here you don't have a graph. Without a graph, how do you... Yes, Alia, any question?
No, teachers.
Okay. So without a graph, how do you find displacement? මෙන්න මෙහෙම. මුලින්ම you calculate the mean velocity. I will choose a different color for this. Question එකක් විදිහට මේක දාන්න. දැන්ට ලියන්න එපා. Don't write anything. Find the height. Excuse me. Find the height. Okay. So this is how you find the height. First of all, you calculate the mean velocity. Height can have a මුලින්ම displacement නේ හොයාගන්න ඕනේ නේද? So we calculate the mean velocity. What is the formula for calculating the mean velocity? Initial velocity plus final velocity divided by 2. This is something we have learned. In this particular motion, initial velocity is 0. So I put 0 ms minus 1. In this particular motion, final velocity is 30. So final velocity mandano 30 ms minus 1 divided by 2. 0 plus 30 is 30. 30 divided by 2, I get 15 ms minus 1 as the mean velocity. Okay. So now I found the mean velocity. Then how do you find displacement? Mean velocity multiplied by time. Mean velocity multiplied by time. Do you remember this method, lamai? Api kata kare meka. When you have to find displacement, what do you do? First, you find the mean velocity. Then you find displacement. Using displacement equals mean velocity multiplied by time. Remember this? Give me a thumbs up. Others? Thumbs up puda adu ivage. Have you forgotten? Monkey way, if you don't revise, you forget. This is something we have learnt already. So here mean velocity is 15 ms minus 1. What is the time taken for this motion, Lamai? What is the time taken for this motion? Just check and tell me from the diagram. Yes. Time taken for the motion is 3 seconds. So time is 3 seconds. 15 multiplied by 3 is 45. So the displacement is 45 meters. When the motion is vertical, displacement is the same as height. So if the displacement is 45 meters, that means height is also 45 meters. So height is equal to displacement. Therefore, height is 45 meters. Is this clear to all of you, Lamai? Give me a thumbs up, everybody. Others? Okay.
Miss,
Yes, Jituri.
Miss, isn't the mean velocity equation is total displacement divided by total time?
That is one of the equations. The method. So, yes, mean velocity has 2 equations. So, good that you asked that question. We'll clarify that. Okay. So, we have learned 2 equations for mean velocity. What are the 2 equations that we have learned? One is total displacement divided by total time. That is one of the equations we have learned for mean velocity. Another equation we have learned is initial velocity plus final velocity divided by 2. Which equation you're going to use depends on the question. If you look at this now, let's say this option number 1, mean velocity equals total displacement over time. Time we know 3 seconds. But is there a way for us to find the total displacement here? Method total displacement because that is what they're asking. We don't have that information. That is what we have to find. Option number 1 what about option number 2? Initial velocity plus final velocity divided by 2? Why? Initial velocity we have, final velocity we have, so you just have to divide it by 2. Is it clear, Jitya? Sorry, Jituli. I'm sorry. Is it clear?
Yes, Miss.
Okay.
Yeah.
I hope it's clear for others also. That's a good question, huh? මේවත් පැටලෙන තැන් ඕගලන්ට ඉස්සරහට. So දැම්මම අහලා එක clarify කරගත්ත එක හොඳයි. Others also might have had the question. ඒකයි මම කියන්නේ සමහරලාට ඕගලන්ට තියෙන question. The questions that you have, others also might have the same question. So if you have a question, just ask it. Then it benefits everybody. Okay? මම එක පැත්තෙන් තියන්නම්. Anyways, so this is our height. So here now we found the height. Height is 45 meters. Still, I will not give you time to write. Still not. Why is that? I'm going to plot a graph for this. Let's plot a graph. A velocity time graph for this same motion. Once we plot this also, I will give you time to write. Huh? Like this. So our y-axis is velocity, x-axis is time. I told you, you have to put the units in the axis, right? Velocity unit is ms minus 1. Time unit is in seconds. Okay. Let's look at our motion. Initial velocity is 0 ms minus 1. At the very beginning, the velocity is 0 ms minus 1. At the very beginning, 0 ms minus 1. After 1 second, velocity is 10 ms minus 1. So 1 second passes. Now the velocity is 10 ms minus 1. So I'm going to mark I will draw the line. Another second passes. So now it's 2 seconds. Now the velocity is 20 ms minus 1. Another 1 second passes. So now the time is 3 seconds. And now the velocity is 30 ms minus 1. 30. So we'll join these and draw the straight line. That is my graph. So this is the velocity time graph of this particular motion. Is that clear, Lamai?
Yes.
Is it clear too? Okay. Then, you know, in a velocity time graph, from the gradient, you get the acceleration. මෙතන මම acceleration හොයන්නේ නැහැ because whenever an object is falling down, acceleration is always 10 because gravitational acceleration is always 10. So object එකක් පල්ලෙහාට වැටෙනකොට always it falls under gravitational acceleration, so it doesn't change. ඒකින්ද මම මෙතන හොයන්න ඕනේ නැහැ because I anyways know it. But displacement. How do you find the displacement of a velocity time graph? Using area under the graph. So I will use that same way to find the displacement here. Now we can see this graph has a shape of a triangle. Area under the graph is a triangle, no see? So I will find the area under the graph. Half into base. Base is 3. Then perpendicular height. Perpendicular height is 30. So 2 times 1 is 2. 2 times 15 is 30. 3 times 15, we get the area as 45. If the area is 45, we know displacement is 45 meters. But if you look at this motion, මේ motion එකේ උඩ පැත්තටනේ තියෙන motion එක vertical no. So displacement is the same as height. If the displacement is 45 meters, we know height is equal to displacement. So if the displacement is 45, height will also be 45 meters. So this is how you find the height when the graph is there. With the graph, this is how you find the height. So, okay. Now let's compare both of these. So this is the motion whenever an object is falling down. I told you velocity keeps increasing. Every second the velocity increases by 10 ms minus 1. So the acceleration, we call it gravitational acceleration, that is 10 ms minus 2. So Mithuna, in both instances, we don't have to calculate acceleration because we know it's 10 ms minus 2 always, because gravitational acceleration is a constant value. However, they might ask you to calculate the height. How do you calculate the height? In a vertical motion, height is the same as displacement. Okay? And we already know how to find the displacement. If you don't have the graph, this is how you find the displacement. Mean velocity equals initial velocity plus final velocity divided by 2. Then displacement equals mean velocity multiplied by time. From there, you get displacement. Since height is equal to displacement, height is also 45 meters. If you have the graph, well, maybe the one don't know. Because when you have the graph, we know this in a velocity time graph, displacement is area under the graph. So area under the graph, this is a triangle. So half into base into perpendicular height. So we do the simplification, we get the area as 45. Therefore, displacement is 45 meters and height is equal to displacement. So height is also 45 meters. A gradient well acceleration because as I said previously, acceleration is a constant value. Is this clear? Give me a thumbs up if it's clear. මේකෙම තව part එකක් තියෙනවා අපිට කතා කරන්න, but let's first of all finish off this. Okay. Now let's write. You have only written the topic, no? Topic එක විතරයිනේ මම ලියන්න කිව්වනේ. So let's write a small point. Star එකක් දාලා ලියන්න ළමයි. Given below is the motion of an object dropped downwards from a certain height. If you have that's why I told you at the very beginning, it's better to have a CR book, then you have plenty of space to write everything. May board එකේ මම ලියලා තියෙන ටික in the same way copy it down to your writing book. It's okay not to use like දැන් මම ගොඩාක් එකේ colors use කරලා තියෙනවා, so you don't have to use all these colors. But if you have like a few colors, better to incorporate. Then your note will be a bit neater. Even when you're revising later on, when you flip through the pages, things quickly go into your head if you have like different colors and all that. But that's totally up to you. Because I know some students don't really like to use different colors. You like only blue and black. Some students really like to have a lot of colors like pinks and blues and oranges. So it depends on your personal preference. But just make sure that at a glance, you understand the note. Everything should be neat. Okay? Quickly write. Become blue, black, red colors. You can write it neatly. Okay, quickly write. So on this side, you draw the motion. You write the mean velocity, that thing. On this side, on this side, you draw the graph. And then you find the height using area. Hope you're writing. Is Maria in the class? Yeah, no? Maria, you understand? Did you understand this? I only saw your message now.
Yes, teacher, I understood.
Okay, all right, no worries. Let me know when you're done, Lama, yeah? You can put in the chat box. Lama, did you all finish writing this part? Who has finished writing this part?
Yes, I finished writing that part.
You finished, okay. Others? I just need to
Done,
get a
yes.
measure done, no? I just need to get a measure of how much time. Okay, some of you have not, okay. Because I will set a timer. For one thing that is good, then you don't like waste time and you will quickly write. For another thing, that will also fix your speed. Um, shall I put a timer for 8 minutes? 8 more minutes? I think that would be more than enough. Okay, quickly do. For the newcomers, you can register for the class from the link that I sent in the main chat. Huh?
Okay, teacher.
Okay. Ikmatali Anna. Otherwise, I'm bored, waiting for you to finish. You have 3 more minutes. Quickly finish because we have to move on to the next part. If you have finished, you can let me know. Others? Give me a thumbs up. Those of you who have finished, give me a thumbs up real fast. Okay. Then who needs more time? Let me know who needs more time. Okay, let's move on. Now we are going to, now earlier 5 minutes would be a bit too much. Shall we discuss this last part? And then I will send the whiteboard note for both the parts. So whatever you missed, leave some space there. And then at the end, I will send the whiteboard note. Okay? Because in the time also, there was only 1 minute left, Nick. 5 minutes දුන්නොත් අපිට අරක discuss කරන්න වෙලාව චුට්ටක් මදි වෙනවා. So we will discuss that. So leave space for what you have not written so far. And we will discuss that, and I will give time to write both. Okay, and then for whatever you cannot write, I will definitely send the whiteboard note. All right. So far, we have been discussing about what happens when you drop an object down. Now, this is what I'm going to do in this time, right? This time, I'm going to throw an object up, right? So I have a question. If I just drop an object, will it ever go up? If I drop an object, will it ever go up?
No.
No, it will always go down because Earth loves things that are falling down, so it will pull it. So if I want to make something move upwards, I have to give it a force, right? I have to make it move upwards. Okay? So this is what I'm going to do. I have an object. So this is my object. So it's starting from the ground level. Now I'm going to throw this up. I told you, if I just drop it, it will never go up. So if I want this to go up, I have to throw it. If I throw it, that means is the initial velocity 0? If I throw it up.
No.
Okay. Others, what do you think? Is initial velocity 0? Is there a value? Yeah, it's not 0. Because if I'm throwing it up, of course, I'm giving it a force, right? So it starts with a certain velocity. So let's say in this particular instance, Mankiana may start curve velocity 40 ms minus 1. So initial velocity is 40 ms minus 1. Now, Lamai, you know the gravitational acceleration is 10 now. That means when an object is falling down, every second the velocity is increasing by 10 meters per second. In the same way, when you throw an object upwards, the acceleration, අපි එකට gravitational acceleration කියලා කියන්න හැ. Because gravitational acceleration means gravity එකෙන් pull කරන එක. If that is 10 ms minus 2, here when something is going up, it is minus 10 ms minus 2. When something is going down, velocity increases, so it's an acceleration. And every second velocity increases by 10, so acceleration is 10 ms minus 2. When you throw an object upwards, every second the velocity decreases. At some point it stops now. That means the velocity decreases. That means it's a deceleration. Deceleration now, it's a minus value. So the acceleration here is minus 10 ms minus 2. This means every second velocity decreases by 10. So let's see what happens. Now the initial velocity is 40 ms minus 1. Now 1 second passes. 1 second passes. Now the velocity of this object is 30 ms minus 1. See, 10 has decreased. Another second passes. Another second has passed. Now the object has a velocity of 20 ms minus 1. And another second has passed. Now the velocity is 10 ms minus 1. Let me move this down a bit. Now the velocity is 10 ms minus 1. That means another 10 has decreased during that 1 second. Then another 1 second passes. Velocity decreases by another 10. Now the velocity is 0. This is where the object stops. Whenever you throw any object upwards, have you noticed that it goes up and at some point it will stop? Have you noticed that? Does it keep on going up and up and up and up? No. When you throw something upwards, it will go up. At some point it stops and will start to fall back down. Right? So this is where the object stops. We are not going to talk about what happens when this falls down, but we are only talking about the upward motion. So this is going up. Initial velocity, because if I'm what was I going to say? Yes, if I'm dropping something, it will never go up. So if I want to make something move upwards, I have to give it a certain force. I have to throw it up. I'm throwing it up means there is an initial velocity. So in this particular case, the initial velocity is 40 ms minus 1. Just like acceleration, gravitational acceleration downwards is 10 ms minus 2. No? So it's the same thing when it goes up, the acceleration is minus 10 ms minus 2. That means every second velocity decreases by 10. In the first second, velocity decreases by 10. Now it's 30. Another second goes, now the velocity is 20. Another second goes, now the velocity is 10. Another second goes, now the velocity is 0. This is where the object stops. So we can see every second velocity decreases by 10. Up to this point, is it clear, Lamai? Everybody give me a thumbs up. Okay. Here also, I'm going to ask you the height. It's pretty simple. If I ask you to find the height, how do you find the height? With a graph එකක් නෑනේ. Find the height. What do you do? Mean velocity හොයනවා මුලින්. Right? Mean velocity. Mean velocity equals initial velocity plus final velocity divided by 2. So there you can calculate the mean velocity. Here the initial velocity is 40 ms minus 1. Lamai, don't leave the Zoom until we finish. Huh? Metrical, let's finish it off. Otherwise, if we leave like a little bit for the next week, no point. No, so let's finish it off. Finish it off. I'm sorry. Finish it off. Initial velocity is 40 ms minus 1 plus final velocity is 0 because that's where it stops. So the final velocity is 0 ms minus 1 divided by 2. So 40 plus 0 is 40. 40 divided by 2 is 20. So the mean velocity is 20 ms minus 1. Now we have to calculate displacement. Displacement equals mean velocity multiplied by time. Here the mean velocity is 20 ms minus 1. In this motion, can you all find the time? What is the time in this motion? Quickly check. Time is there.
4 seconds.
4 seconds, right? So here, 1, 2, 3, 4. It's 4 seconds. So time is 4 seconds. 20 times 4 is 80. So displacement is 80 meters. And we know height is equal to displacement. Since displacement is 80 meters, height is also 80 meters. So that is how we do this without a graph. I will draw the graph version. Okay. Now let's draw a graph to this. Now this is a bit important. Don't worry about the class finishing time or make a liagana time. Again, worry when first listen. Let's draw the graph. So we know here y-axis is velocity. Unit is ms minus 1. X-axis is time. Unit is seconds. If you look at this particular motion, when the time is 0, that means the motion is about to start. As the motion starts, time means 0. But it already has a velocity. Time is 0, but the velocity is 40. Time is 0, but the velocity is 40. Then 1 second passes, now the velocity is 30. 1 second passes, now the velocity is 30. So now the velocity is 30. Another 1 second passes, so now the time is 2 seconds. Now the velocity is 20. Now the velocity is 20. Another 1 second passes, now the velocity is 10. And now the time is 3. Now velocity is 10. Another 1 second passes, so now the time is 4, velocity is 0. Now the velocity is 0. Can velocity method is 0. So you just have to join these and draw a straight line. I don't think my straight line will be very nice. Let's see. Should be something like this. So like this. This is 40. Is the graph clear to you? Lamai? Give me a thumbs up. You know, from the graph, if you get the gradient, from the gradient, you can calculate acceleration. But as I said earlier also, there was no point calculating acceleration because whenever an object falls down, the acceleration is always the gravitational acceleration, which is 10 ms minus 2. Methanath, it's the same story. We don't have to calculate the acceleration here using the gradient because whenever we throw an object upwards, the acceleration is always minus 10 ms minus 2. That is always that. So it doesn't change. So therefore, we don't have to calculate the acceleration using the gradient. However, just like this one, we can calculate the height. Here, how did we calculate the height? Mean velocity hoela, then displacement hoela, then only we got the height. Here, we don't have to do that because we have a graph. Find the height. And we know in a graph, how do we find the height? Using the area under the graph. Area. And since this is a triangle, area is half into base is 4. Perpendicular height is 40. So, I'm sorry. 2 times 1 is 2. 2 times 2 is 4. So 2 times 40 is 80. Area 80 means we know from area under the graph, we get the displacement. Displacement is 80 meters. And we know in a vertical motion, displacement is the same as height. Therefore, height equals displacement. Since displacement is 80 meters, height is also 80 meters. So same answer as here we got, but in 2 different ways. Here also we got 80, here also we got 80, but 2 different ways. Up to that point, is everything clear to you? All right, so let's start writing. Metana venom topic ekak daganna, given below. Put a point, given below is the motion of an object thrown upwards. So put that point and write this. To write this entire thing, I will give you like 8 minutes, 8 to 9 minutes. Don't leave the Zoom until you finish. Huh? Don't leave the Zoom, just write it really fast. You have about 4 more minutes. I hope everyone's writing. Some of you are done. Okay. Okay, give me a thumbs up if you have finished. Who needs more time? Because I don't want to drag the class until very late. That's why. Anybody who needs more time? Okay. 2 more minutes. Okay. So while you all copy this down, I will give you homework. Now we talked about gravitational acceleration, what happens when you drop an object down, when you throw an object upwards, and then what happens to the graph. All of that we have discussed. So go to the miscellaneous exercise. On page 49, do question number 5 and 6. Miscellaneous exercise, question number 5 and 6. I will put in the group as well. Give me a second. What is today's date? 17th February, no? Miscellaneous exercise, page 49. What are the questions that I said? 5 and 6. I sent in the group as well. Okay, so we'll slowly wrap up. All the newcomers, if you are interested in continuing the class, you can either register to the link that I sent in the main chat. And if not, you can let us know on WhatsApp within today and tomorrow. And also, now we're finally done with the lesson. I was hoping to start the 3rd lesson today, but unfortunately, we didn't have time because a little bit more time was taken to discuss homework. So it's okay. We'll start it tomorrow. We'll start it next week. Actually, my good thing we didn't start the 3rd lesson today because I have to send you a note. Then tamai api unna printed notes use karana patan ganne. I will tell you how that works. Give me 1 minute. For certain lessons, I will send you a PDF. because it's not practical for us to write all the lessons. No, in the school, of course, you meet like you go to school 5 days a week and you have time. But class එක එහෙම නෙවෙයි අපි week එකට එක දවසයි හම්බ වෙන්නේ. So we have very much limited time but a big syllabus to finish. Therefore, some of the lessons දැන් සමහර biology ඒවා හැම නිකම් බොරුවට ලියන එක වැඩක් නැහැනේ. බොරුවට වෙලාව යනවා. Therefore, I give you a PDF and you have to take a printout because I can't give you a printout, no. So I will send you the PDF. You take a printout and you have to bring it to the next class. So there are certain lessons that we cover using printouts. Only certain parts we will write in the writing book. So third lesson is such a lesson. Yes. So we will be doing that lesson using a printed note. So by Thursday, that means day after tomorrow, I will send you a PDF for the third note, third lesson. Can you all take a printout and come before next Tuesday? Okay, so all of you take a printout and come. Black and white, I mean, colors, but don't worry, you can just take a black and white printout and bring it to the next week class. Because the printout you will be lost because you won't have the note. So make sure that you get the printout and come. By Thursday, I will definitely send you. Thursday is day after tomorrow. Yes, I will send you that note. Okay, so shall we wrap up? I think we took 15 more minutes. It's okay. So before we wrap up, before we stop the class, from everything that we did today, is everything crystal clear? If you have any doubts, any questions, any concerns, you can ask now. If not, if everything is all clear, you can give me a thumbs up. Okay. Seems like everything is okay. So we will meet each other next week, which is 24th of February, last week of February. Until we meet next week, have a great week and see you. Good night, Lamai.
Thank you and good night, teacher.
Okay.
Good night, teacher. Thank you so much.
You all sound very sleepy, no?